So at station one, you're looking at graphs and trying to identify whether they are linear or non-linear. So when you're looking at a visual representation like a graph, you have to depend on interpreting the properties of what you're looking at to identify it as linear or non-linear. And with graphs, it's actually pretty straightforward. So something that's linear will manifest visually as a straight line. So when we look at the two graphs we have here, these are the first and second graphs you were given. The one on the left clearly looks to be a straight line. So we're going to classify that one as linear. And so one of the key characteristics of a linear graph is that it looks like a straight line. So that's a pretty obvious one. But we can also make some inferences about other properties of the graph. And one of the key properties of any linear graph is something called slope, which hopefully you have learned about before. And the slope would be the steepness of the line, which is assessed based on the rise and the run of the line, or how much it goes over for every unit it goes up. So basically, if we look at the rise and run of this particular graph, we can see that we rise 2 and run 1, or rise 5 actually, if we look at the scale of the graph. So we rise 5 and run 1, we rise another 5, run 1, rise another 5, run 1. So you'll see that the slope that's being created or generated by this relationship is always constant, and that's a key feature of a linear relationship. The slope is constant or always the same, no matter which 2 points you're looking at. Now, for a nonlinear relationship, it changes a little bit. And the key defining feature of a nonlinear relationship is, as you would expect, that it does not look like a line. So if we look at the one on the right, this one would be clearly classified as nonlinear. And as I said, just from the term itself, you can tell that this means that it is not a straight line and usually looks like a curve. And you can see that here, it clearly sort of curves, almost looks like a bit of a squiggle as we go. And it doesn't, nonlinear relationships won't always look like this particular one, but they will never be just a straight line. They will always have some kind of curve to them. And how this relates to the characteristic we were looking at before, which is slope, is that the slope is not constant throughout the relationship. So you can see here, for example, in the middle, the slope is flat here. Off to the side here, the slope is not flat, but it's not terribly steep. Whereas when you get further up, the slope gets steeper if you were to trace along the line. So the slope is not constant and changes at different points. And that's a key feature of a non-linear graph.